Hello friends, welcome back to our channel. So today we'll see one more concept in discrete mathematics, that is graph representation. So in our previous session we have seen what is a graph and what are the different types of graphs. So we have seen around 10 variety of graphs. So now we'll see how can we represent that graph, right? So one common way to represent that graph is in a matrix format. So there are three types of representations. So let's start the session. Representation of graphs. Representation of graphs. So commonly any graph can be represented by using the matrix format. So the first format is incident matrix. Incident matrix. So there are three formats. One is an incident matrix, another one is a path matrix, and the adjacency matrix. Now let us see about the incident matrix. What is an incident and how we can see this matrix, right? So first of all, incident. What is this incident? So incident being an edge between two vertices. If the edge between two vertices is there, that we can call it as an incident of that particular edge, right? So based upon the edges, we need to fill the matrix. So if I of G, so I stands for incident, right? Incident matrix of G is equal to, in matrix, let us take some Mij. So this is the elements. Mij are multiple elements. So the Mij will become 1. Okay, will become 1 if there is an incident edge between between the vertices. Between the vertices, right? And 0 otherwise, if there is no edge. Okay, and all these things will be for undirected. So if there is no direction, then we can consider, if there is any incident for an edge, then we can consider it as 1, otherwise we can consider it as a 0. Example. So you might be having some confusion regarding this one. So let us solve one example so that you can understand this one. So I am taking this graph. So this is an undirected graph. So there should not be directions here. So this is a graph, right? So for example, let us take, it is a edge 1, edge 2, edge 3, edge 4. So 4 edges. Now for this graph, how can we construct the incident matrix? Okay, how can we consider the incident matrix? So on the rows, we have to consider the vertices. How many vertices are there? 4 vertices are there. So columns are edges because this is based upon the incident. Incident is an edge. So E1, E2, E3, E4. Now you can consider, see, A is having 2 incidents. So that means E1 and E4. So A to E1 will be 1, A to E4 will also be 1. And AC, there is no incident. Okay, AC there is no incident. Only for edge 1 and edge 4 are the 2 incidents for going out from the A. So all the remaining becomes 0. Now coming to B. So B having 2 incidents, E1 and E2. So B, E1 and E2. So E1 1, E2 1, and the remaining are zeros. So there is no incident of E3 and E4. Now coming to C, there are 2 incidents, E2 and E3. So E1 becomes 0, E2 becomes 1, E3 becomes 1, and E4 becomes 0. And D is having 2 incidents, E4 and E3. Okay, so there is no direction. So if it may be incoming or it may be outgoing, so you can consider the edges and we can place it as a 1. So E4 and E3 are the 2 incidents of D. E4, E3. So E1, E2 will be 0 and E3, E4 will be 1. So this is how we can construct the incident matrix. So for that incident, so for particular vertex, what are the incidents? So or you can simply use E1. E1 is having a two incidents, right? A, B. So you can fill it as A, B. E2 is having two vertices, B, C. You can write it E2, B, C. E3, C, D, C, D. E4, DA, DA, or else A having two incidents, E1, E4, E1, E4. This is a row wise. B is having E1, E2, B is having E1, E2. C is having U2, E3, E2, E3. D is having E3, E4, E3, E4. So you can consider anything, but based upon the edges, we have to fill the incident matrix. And this is only for undirected, so there should not be directions. So if it is an directed, if it is a directed, then also we have to consider, but if vertex I is the initial vertex of edge J. So there, one edge will be having two vertices, right? If that vertex is an initial vertex, then you have to place it as 1. And there will be one more thing, that is a -1 if vertex Vi is the final vertex of edge J. That means, for example, let us take A, B. So there is a undirected edge. So A to B can be considered and B to A can be considered. For example, if the direction is in this way, so that will be the directed. So A, B will be considered. There is no path towards B to A. So A becomes, so if it is a E, J, this is Vi, A becomes the initial vertex, B becomes the final vertex. So A we have to give 1 and for B we have to give a -1. So three terms, okay. Ij can become three terms, 1, -1, 0. If vertex is the initial vertex of edge, we can consider it as a 1. If it is a final vertex of edge, we can consider it as a -1. So this is also incident matrix. Now you can consider this example. I'll take this example. See. Now this is a directed graph. Okay. So one thing you have to remember, there should not be loops. Okay, there should not be loops. So this is a connected, directed, cyclic graph. Okay, now there are the edges. So with the directions, previously there is no direction. So now how can we fill this incident matrix for directed graph? How we can do? See, E1. So A is having, okay, A is having two edges. Okay, one is E1. So for E1, the edge is a final vertex. A is a initial vertex. So for E1, we can consider 1 as a initial. Okay, and E4. For E4, it is a final. So for E4, we can consider it as a -1. So there is no edges E2 and E3. Coming to B, E1 is having the edge, but B becomes the final vertex. So for E1 we have to consider -1 and E2, that is the initial one, so 1, it will be 0, 0. For C, E2 it is a final, so -1. E3 it is the initial, it is 1, so it becomes 0, 0. And for D, E3 will be final, E3 will be final, E4 will be the initial, so it will be 1 and it will be 0, 0. Hope you understood. Consider one edge. So this will be the initial vertex and this will be the final vertex. If the vertex is initial, we have to fill with 1. If the vertex is a final vertex, it should be represented with a -1. So that is the difference between a directed incidence matrix and an undirected graph incident matrix. Right? So hope you understood this one. Next we move on with the next one, that is a path matrix. Path matrix. So based upon path, we have to consider the value, right? So this is a path matrix. So here also this can be considered as a PG, where P is a path matrix, is equal to, so we can consider Mij are the elements, and the Mij will be holding the values 1 if the vertex can be reached from another vertex, and 0 otherwise. Simply we can consider if there is path, then it becomes 1, and if no path, it will be 0. If there is path, we can consider it as a 1, and if there is no path, we can consider it as a 0. For example, let us consider the same thing. So I will go with the same A, B, C, D, C. So this will be E1, E2, E3, E4. Now, based upon not the vertices, based upon not the edges, we have to consider the path. If there is a path to reach the destination, then we can consider it as a 1. So I'll write rows can be represented with the vertices. Similarly, columns will also be represented with the vertices A, B, C, D. Now A. So start from A, and if you reach to A again, then we can consider it as a 1. So if you go with A, then A to B there is a path, B to C there is a path, C to D, and D to A. So we are starting from A, we are reaching to A. So we can consider it as a 1. If there is no path, automatically we can consider it as a 0. For example, now A to B. So there is an edge directly, yes, 1. A to C, yes. A to B, B to C, yes. A to D, A to B, B to C, C to D, D to A. Right, A to D, right? Next, B to A. B to A, there is no direct edge. So we have to check whether there is an indirect. B to C, C to D, D to A. Yes. B to B, B to C, C to D, D to A, A to B. B to C, there is a direct edge. B to D, B to C, C to D. So we can reach D. So we are starting from B, and we have to check whether we can reach this particular vertex or not. So C to A, there is no direct. So but we can travel from C to D and D to A. Yes. C to B, there is no direct. C to D, D to A, A to B. Yes, we can reach. C to C, C to D, D to A to B, B to C. Yes, we can reach. C to D, there is a direct edge. Yes. And D to A, there is a direct edge. D to B, D to A to B. Yes. D to C, there is no direct, because this is a directed edge, right? There is no edge between D and C, D to C. So D to A to B, B to C. Yes. Next, D to D, D to A to B, B to C, C to D. Yes. So this will be the path matrix. So we have to verify whether we will be starting from one vertex and whether we can reach to that particular another vertex or not. So here we are considering A as a one vertex, and A to A means we have to start from A and we have to reach to A. And next, A to B, we have to start from A to B. So it doesn't mean that there should be a direct edge between those vertices. So directly or indirectly, the edge should be, there should be a path which starts with one vertex and reaches to the another vertex. So that may be either direct or indirect. Okay, towards the intermediate vertices also we can reach the destination. So if such case is there, we have to consider it as a 1. If there is no path, then we can consider it as a 0. So that is a path matrix. Hope you understood. Now we'll move on with the next one, that is a adjacency matrix. Adjacency matrix. So that can be represented as AG. Adjacency matrix. and simple. Here we need to check with the edges, right? So if edge between Vi to Vj, then simply we can consider it as a 1. If there is no edge between Vi to Vj, we can consider it as a 0. For example, let us take same example. Let us take the same example. So A to A, there is no edge. Simply we can consider it as a 0. A to B, yes, there is an edge. A to C, there is no edge. You can consider. So we are directly watching about the edges, direct edges. So A to C, there is no edge, 0. A to D, there is no edge because this is a directed. This is a directed, right? So there is an edge between D to A. There is no edge between A to D. So it will be 0. And B to A, there is an edge between A to B because the direction is towards B. So there is no edge between B to A. So obviously it will be 0. B to B, there is no self loop, so it will be 0. B to C, there is an edge, right? So there is an edge between B to C because the direction towards C only, right? It's 1. And B to D, there is no edge, 0. C to A, there is no edge, 0. C to B, so there is an edge, but it is a directed edge which is coming towards the C, but not going away from C. So C to B, there is no edge, 0. C to C, there is no self loop, 0. C to D, there is a direct edge, yes, 1. And D to A, there is an edge, 1. D to B, there is no edge, 0. D to C, there is an edge between C to D, but it doesn't happen, so it will be 0. And D to D, there is no self loop, so it will be 0. So this is called, here we are not verifying about the path, we are only checking about the edges between the vertices. If there is an edge between the vertices, then we can consider that as a 1, otherwise we can consider it as a 0. So the representation is also similar. For adjacency matrix, we will be representing it as AG. For path matrix, it will be represented as PG. And for incidence matrix, we can represent it as IG. Right? So incident matrix means based upon the incidence of that particular edges, we have to construct the incident matrix. And for both directed and undirected, the procedure will be different. The values will be different, right? And for path, so if there is any path to reach the destination, then we can simply fill it with 1, otherwise it will be 0. And here we have to consider only the edges. If there is a direct edge between two vertices, we can consider it as a 1, and otherwise it can be considered as a 0. Right? So these are the different ways of representation of graphs. So 3 types of matrices. So hope you understood this one, and if you feel any difficulty regarding this one or any confusion, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.